So this video is going to show you the molecular formula part. We've learned the empirical formula. The definition here says the exact formula of a compound, not always the lowest possible form. So for example, I could have CO2. All right, that means that's a 1-to-2 ratio. Now, the 1-to-2 can't be reduced down anymore. So you can say that this is your empirical formula. But say I have a compound that is actually C4H8. Okay, this is not reduced down as much as possible because 4 to 8 can be reduced down to 1 to 2. So this is my molecular formula. Now, if you look at CO2 and compare it to C4H8, C4H8 is 4 times bigger than CO2. So what you technically could say is that this is 4 times CO2. And that way it's C4H8, sort of like you would distribute in math. All right, so the way that we find the molecular formula is we find the empirical formula. If it's already given to you, then you're fine. The next step is to find the molar mass of the empirical formula. So let's do practice number 1 and go through those steps. A compound has a molar mass of 220.1 and an empirical formula of CO2. What is the molecular formula? Well, the first part, step 1, says find the empirical formula. It tells me here that there's the empirical formula. I'm going to label that EF. That's not always the case, though. Sometimes you will be given percentages, like you were given percentages on the front practice, and you have to find the empirical formula. In this problem, it already tells you. Then you find the molar mass of the empirical formula. So my empirical formula is CO2. If I find the molar mass of it, there's 1 carbon, 12.01. There are 2 oxygens, 16.00, 32. My total here is 44.01 grams per mole. So I found the molar mass of the empirical formula. Step 3 says must be given molar mass of the molecular formula. Well, if I look at the problem, a compound has a molar mass of 220.1. This is my molar mass of the molecular formula, which I'm going to shorten as MF. Step 4, set up the equation so that you have molar mass of empirical formula times X equals molar mass of molecular formula and solve for X. Okay, so I'm going to write molar mass of empirical formula. I found that to be 44.01 times X equals the molar mass of the molecular formula, which it tells me is 220.1. Now I just solve for X. Divide by 44.01 to solve for X. Your X answer in this case would be 5. Okay, now that I've solved for X, it says step 5, multiply subscripts of the EF of the empirical formula by X to get the final molecular formula. So what this 5 tells me is that my molecular compound is actually 5 times bigger than the empirical formula. So multiply subscripts of EF. So I'm going to take CO2 and times it by 5, basically, because the molecular is 5 times bigger than the empirical formula. So this becomes C5O10 because C, there's 1 of them. If I'm distributing, though, the 5 times 1 gives me C5. The 2 times 5 gives me 10. All right, so that's how you do the first one. Let's look at number 2. Number 2 says a compound contains 83.625% carbon, 16.375% hydrogen. Molecular weight is 388.78. What is the molecular formula? So pause the video if you understand, and if you don't, then watch the video with me. First step is to find the empirical formula. Well, here I don't have the empirical formula, but I do have the percentages. So I'm going to find the empirical formula the way I did it in the work from the other day. All right, so carbon, 83.625. Sorry, that should be grams because you change your percentages to grams. 1 mole divided by 12.01 grams. My answer here is 6.96. Hydrogen, 16.375 grams. 1 mole, 1.008. My answer there is 16.25. I divide by the smallest of the numbers, 6.96. Get 1 there, 0.96. I get 2.33. Now remember that with the empirical formula, if you have something that ends in 0.3, whether it's 0.33, 0.35, 0.36, doesn't matter. Multiply all ratios by 3, then round to whole number. So I'm going to take my ratios, 1 and 2.3, and times it by 3. Here I get 3. Down here I get 7. Okay, now I can plug this in C3H7. This I'm going to label as my empirical formula because that's all I found right now. So you did step 1. Step 2, find the molar mass of the empirical formula. Well, I'm going to skip a bunch of steps and just tell you that the empirical formula here is 43.086 grams per mole. You find its molar mass the way we've done it since the beginning of this unit. Step 3, must be given molar mass of the molecular formula. It says the molecular weight is 388.78. So there it is. Molecular formula weight. Step 4, set up the equation so that you have molar mass of EF. So molar mass 43.086 of EF times X equals molar mass of MF, and that's the 388.78. I solve for X, and I find that X equals 9. It equals 8.99, I think, in your calculator, but you can just round it to 9. So that means that my molecular formula is 9 times bigger than the empirical formula. So step 5, the final step, multiply subscripts of EF by X to get the final molecular formula. So 9 times the C3H7, and this is going to give me C27H63, because 9 times 3 is 27, 9 times 7 is 63. That's how I get my answer.